Hi, Calc students. So we're going to be working with parametric equations today. Hopefully you've had a chance to watch the Khan Academy video as an introduction to this topic. Please watch that before you go through these notes and have your notes handy as I go through these examples. So I'm going to share my screen and you can follow along with your notes as we go through the problems. All right, so if we look at, let's back up here. Come on. All right, so slide number 1 here, it says for t is greater than or equal to 0, a particle is moving along a curve. So its position at time t is x of t, y of t, where y of t is equal to 4 sine t squared minus 1 plus 3. And the graph below contains a portion of x of t, which is 2 line segments and a quadratic function defined by 1/2 t minus 8 squared plus 2 for this section here from 6 to 10. So the first part says find the equational line tangent to the path of the particle at t equals 1. So to write the equation of the tangent line, we're going to need a point and a slope. If you look at your notes to find the slope, which let me grab my pen. Our slope dy dx is found by doing dy dt over dx dt, where hopefully dx dt is not equal to 0, which we can see in this case it is not. All right, so we're going to need a couple of things. One thing we're going to need is the derivative of y, which is given as this y of t equals 4 sine. So we're going to do y prime of t is equal to, and if I take the derivative of sine, I get cosine, so 4 cosine t squared minus 1. And then we need a chain rule, so the derivative of t squared is 2t. And then we have the derivative of 3, which is just 0. So this turns into 8t times a cosine of t squared minus 1. So that's y prime of t. So then if we do y prime of 1, which we're trying to find the equation of the tangent line at t equals 1, y prime of 1 is equal to 8 times 1 times the cosine of 1 squared is 1 minus 1 is 0, and the cosine of 0 is 1, so this turns into 8. All right, we're also going to need x prime, which is the slope here, so x prime of t, and if we're doing it at 1, we're finding the slope of this at 1. We're just getting it right from the graph. So at 1, it looks like our slope is 2 over 1, so x prime of 1 is 2. So that gets us our slope, our dy dx, is equal to dx dt, which we found was 8, and our dy dt was 8, and our dx dt is 2, so our slope is 4 at t equals 1. And so now we need to find what the coordinates are when t equals 1. So x of 1, again, I can get this straight from the graph. X of 1 is 2. To find y of 1, I'm going to plug it into this 4 sine. So I have 4 sine, and I'm going to have 1 squared minus 1, which is going to be 0, plus 3. The sine of 0 is 0, so 4 times 0 is 0, so this turns out to be 3. So we know at t equals 1, we have the point 2, 3. So our equation turns into y minus 3 equals 4 times x minus 2. All right, so that's part A, the equation of the tangent line. In part B, it says, is the horizontal movement of the particle to the left or to the right at t equals 7? So horizontal movement has to do with the x coordinate. So the question is, oops, let's go back. I didn't have my pen. So we're looking for what is x prime of 7. So if we look at that, 7 falls into that range of 6 to 10. So I can find the derivative, x prime of t, because remember x of t is defined for that parabola there, the 6 to 10 region. So x prime of t would be 2 times a half is 1 times t minus 8. 2 minus 1 is 1, so that's x prime of t. And if I do x prime of 7, I'm going to get 7 minus 8 is negative 1. And since this value is less than 0, the particle is moving to the left. Some nice writing there. All right, let's look at part C this time. It says at time t, a particle moving in the, new example. At time t, a particle moving in the xy plane is at position x of t, y of t, where x of t, y of t equals, and we have a cubic function there and a quadratic. At what time is the particle at rest? So a particle at rest with parametric functions is where both x prime of t and y prime of t are each equal to 0. So I need to find x prime of t. So x prime of t, I take the derivative of that cubic function, and I will get 3t squared minus 12t plus 9, and y prime of t, if I take the derivative of that quadratic, I get 6 minus 2t. So I want to know where each of these is equal to 0. So this first one, I'm going to start by factoring. And I can take a 3 out of everything. And that gives me t squared minus 4t plus 3. And luckily, I have a nice factorable quadratic there. So I have t minus 3 and t minus 1. And sorry, the pen is coming out so strangely. So if I set that equal to 0, this part, I'm going to have 2 different times that the particle is at rest. For the x coordinate, t equals 3 and t equals 1. But remember, I'm looking for where they're both 0. So this time I'm going to set 6 minus 2t equal to 0. So I'm going to get 2t equals 6. And if I solve for t, I get t is equal to 3. So the point at which the particle is at rest is where both of these are at 0, and it has to be in agreement there. And so our answer would be at t equals 3. All right, example 3, we have our buddy Randy the Roach. He's moving in the xy plane. At time t, his position is given by the parametric equations x of t, y of t, where dx dt is 3t and dy dt is t squared. So this time we're given the derivatives. And it says, find the distance Randy traveled from t equals 0 to t equals 15. And this is one where we're allowed to use our calculator on here. So I'm going to set up the integral, and this is how you'll have to do it on the exam too. They'll give you these problems, and you'll have to set up your integral. So if it's finding the distance that he traveled, that's looking for the arc length. Notice the arc length for parametric is a little different from the formula that we had for the arc length of just a general curve. The one for parametrics, it does come from the other one, but you will need to know both forms. So our arc length is equal to the integral, in this case from 0 to the square root of 15. And it is the square root of dx dt squared, or 3t squared, plus dy dt squared dt. And you could actually, this is a calculator question, you could at this point just go ahead and plug it into your calculator, but I'm going to simplify it a little bit. It is the square root of 9t squared plus t to the 4th dt. So grab your calculator, set up the integral, and hopefully you should get that the distance Randy travels from t equals 0 to t equals 15 is, and I'm getting, I think I did it by hand here. I didn't use a calculator, and I got 16 root 6 minus 9, which using your calculator is about 30.192. Okay, so this was a calculator question, but it wasn't that hard to find that integral either. All right, let's look at our next example. It's a long one. This is a pretty typical one that you're going to find on the AP exam. It says at time t, the position of a particle moving the xy plane is given by the parametric functions x of t, y of t, and again, we get a derivative for dx dt. For y, it's one of these where they give us a, let me move this out of the way. They give us a graph of y of t. And it's just 4 line segments. When t equals 0, the particle is at the point 4, 7. Okay, so this is going to come into play later when we're trying to find the position of the particle, because we know at time 0, it's at the position 4, 7. All right, so part A, again, is find the slope of the line tangent to the path of the particle at t equals 3. Again, to find the, oops, forgot my pen again. Okay, again, to find the slope of the tangent line, we are going to be doing dy dx is equal to dy dt over dx dt. All right, so this is the graph of y. So I can do my slope at t equals 3 right here, and it looks like that's going to be, looks like a -2. So the top part of this is a -2. We're getting right from the graph. We're going to have to calculate oh no, we have dx dt, but we're doing it for t equals 3. So dx dt for t equals 3. Oh, that should say dt. That's a typo. I have to fix that. At t equals 3, I'm going to plug 3 into there, and I'm going to get 3 squared is 9 plus the sine of 9. All right, so our slope is -2 over 9 plus sine 9. So in this case, that is going to be equal to about 9.6, oh no, negative, oops, I'm looking at the wrong problem, sorry. Dy dx is about, and I'm going to say that this is at t equals 3, is about a negative 0.212. Okay. Let's look at part B. So part B is find the speed of the particle at t equals 3. Our formula for speed is the square root of dx dt squared, which in this case was our 9 plus sine 9, plus, and we need our slope at 3 of y was our -2, right? Our slope was down 2/1, so -2. So we have -2 squared. And if we calculate that, it is about, that's our 9.622. All right, part C asks, find the position of the particle at t equals 3. So to find the position of the particle, let's first of all, we're going to need both the x and the y coordinate of that position. So if I do x of 3, that's going to be our initial position plus the integral from 0 to 3 of x prime of t dt. All right, so if you remember at the very beginning of the problem, they told us our initial position of the particle at t equals 0 was 4, 7. So x of 0 then is 4. And here I'm doing the integral from 0 to 3 of x prime of t dt, which is just 0 to 3 of x of t. And that is, if I calculate this, this is this x prime of t was given to us t squared plus sine of t squared. And again, this is a calculator problem. And you'd find that out in a hurry if you tried to find the antiderivative of this. So if I calculate that, I'm going to have 4 plus, this integral works out to be about 9.77356, or about 13.774. And if we find our y position, and for y of 3, we're going to look at the graph. And if I look at the graph, y of 3 is equal to 4. So remember, let's see, is that right? Y of 3 is 4. Yep. And so the position of the particle at t equals 3 should be 13.774, comma 4. All right, let's look at part D. Find the equation of the line tangent to the path of the particle at t equals 3. We've done several of these. We now know the point when t equals 3. We know it passes through the point. We got our x of 3, excuse me, our x of 3 from the last problem. Remember, let's see if I can do this. Third time's a charm. Okay, so x of 3 was our 13.774. Oop. Sorry, I forgot I'm doing the equation of the tangent line problem. So again, x of 3 is our 13.774. And our y of 3 was 4. And we have our slope from part A, which was our negative 0.212. So our equation is y minus 4 equals negative 0.212 times x minus 13.774. All right, let's look at part E this time. Part E says find the total distance traveled by the particle from t equals 0 to t equals 4. And so again, we're looking for our arc length when we do this, when we look for the distance traveled. So it's going to be the integral from 0 to 4 of the square root of dx dt squared plus dy dt squared. All right, so if I try that, if I look, dx dt is going to stay the same throughout, but if I look at my dy dt here, it changes as I go from 0 to 4. So if I look this part of it, this part dy dt is equal to, it looks like a positive 3, right? I'm going up 3 over 1. For this part of the curve, from 2 to 4, my slope is a negative 2. And so I actually have to split this integral in two parts. First, I have the integral from 0 to 4, from 0 to 2 of the square root of dx dt, and that's our t squared plus the sine of t squared. That quantity squared plus, and again, dy dt in this stretch is 3 squared dt plus, I'm going to need the second integral, which is going from 2 to 4. And this time I have the square root of, and our x doesn't change. It's still t squared plus the sine of t squared squared. But this time our slope is negative 2 for dy dt. So I have negative 2 squared. Again, this is a calculator problem. You can use your calculator to evaluate those. Again, this is our arc length, which we split into these two. So our arc length is about equal to, this first integral comes out to be about 7.249, and I took it out to a bunch of places just to be sure. And then the second integral comes out to be about 19. That's a 9.12434. So the total distance traveled of the particle over the integral 0 to 4 is going to be 26.373. All right, that's our last part. Your assignment for this today is in your book, and you can find those problems that I've assigned on today's agenda. All right, good luck.